All right. Good afternoon, everybody, and thanks for having me here. Thanks for the great introduction, Dr. Hu. I think that painted a good picture of the industry as a whole, where we've been and where we're going, and so I think it's very helpful for us, so I appreciate that. So I'm Matthew Festo from Intrinsic. I'm the general manager of our Singapore office. We know who is Intrinsic. I'm going to tell you a little bit now. We're based in Mountain View. We have an office in Munich and then one in Singapore, covering the different regions. And I'll tell you a bit about what we're doing in the industry and a bit about how we're pursuing artificial specialized intelligence for the robotics industry and industrial manufacturing. There we go. Okay, so you got a very good introduction of the industry, some of the problems we're facing, and for those of you that are from industrial manufacturing, you're very familiar with this information. Basically, the industry is transforming, and we're at a really exciting time because of how robotics and AI are transforming what we're able to do. So the costs of machines and equipment and sensors are coming down while the capabilities are improving. We're starting to hit a bottleneck in software integration, where we can do things a little bit faster or make things a bit more interoperable. And so that's what Intrinsic is pursuing, is a way to make us more efficient, to improve the possibilities of industrial automation, reduce the costs, and reduce the development times as well. So we're building an AI-enabled robotics platform. The AI models that we see all over the world today are amazing. And sometimes also very entertaining for some of the bloopers that we see as well. We want to help bring AI-enabled models into production-ready models that you can deliver out onto the factory floor. And so we're doing that with a platform. The platform, I have a few examples up here that are kind of toy examples, but just to illustrate some of the capabilities that we're pursuing, you can see from left to right, we have maybe a connector insertion model. We have a complex contour following model that you can use, and also a way to visualize a world, even with some difficult objects, using kind of point clouds to figure your robotics plan to maneuver around your work cell. And these toy models, in order to put them into use in a production environment, you need to have a reliable and robust platform and operating system to deliver that into a factory. And so we're doing that by building a cloud-first software, but we also have an industrial edge stack as well running in the factory, and we're doing that with a real-time software stack to implement the sense, think, act loop typical of robotics in the factory, but also make it a connected developer tool. So I mentioned we're building an AI platform, and we're building something that's AI, robotics, hardware, and other software agnostic as well. So what we mean by that is we want to be able to partner with many different companies to bring the best of what each one has to offer to connect together and collaborate across this very diverse world of solutions that we talked about in the beginning. Intrinsic is part of the Alphabet family, so we're a wholly owned subsidiary of Alphabet, which means we have some very helpful big brothers and sisters in Google Cloud and Gemini and Google DeepMind and even Android from the platform perspective, so we can learn from their wisdom, but we can also collaborate with them as well on some of the projects and have maybe a closer relationship because of that. And it gives us a benefit. But we're not building our platform for Alphabet. We're building our platform for the industrial robotics industry. And so we're also partnering with companies outside of Alphabet, such as NVIDIA, such as the ROS, the Robot Operating System, the open source software platform that's powering many robots around the world, and research institutions around the world as well. And we're doing this to build this AI integrated platform. We're building a IDE or a developer environment for solution builders to create or imagine how they could solve a problem from an end customer. We're providing a few AI skills out of the box to get started, but it's meant to be a flexible, expandable platform and tool, and we'll get into that a little bit more. We're building that with a simulation-first environment in mind. So digital twin, a real digital twin, connecting the physical environment with the simulated environment in a closed loop. And we're doing this with a real-time software stack, so we're actually connecting to the robot controllers and talking to them directly, as opposed to maybe a more traditional approach of offline programming and then using another software stack to control the robot itself. We're building an end-to-end solution. So this is kind of a first look at what FlowState is. FlowState is our first product that we launched. It's targeted for what we call solution builders. These are the people, maybe at a system integrator, maybe at another company, that are understanding what the end customer needs, understanding automation requirements, and figuring out a way to solve that problem using robotics, automation, and AI. And so it's a simulation-first environment, like I said, so you can see the digital twin as it scrolls through, where you're visualizing your model. But it also is a remote collaboration tool. So it's a web-based tool that we're using. You can collaborate anywhere in the world. We frequently have our engineers in our Singapore office solving a problem with our engineers in the Mountain View office on a physical hardware cell. And we can connect those directly using some of the infrastructure and plumbing that we've put together for this. So I'm going to give you some examples on a couple slides about the AI capabilities, but we have a few out of the box to get things started. We have a vision of building this platform. To make that vision reality, we have to provide some tools, some use cases, some templates, and so we're doing that with our first tool, FlowState, here. And as the video you saw, that's probably not something you want to put onto your factory floor, so we also have the ability to create a custom HMI so that you can put the normal work instruction of your factory or the work instruction layout of your factory in front of the user, but in the back end you can still connect into FlowState and expose some of the parameters that you would like to use. So we're building a platform. Our first tool is FlowState, and it's an end-to-end developer tool. And what we mean by that is the solution builder is kind of the first stakeholder. They create they imagine and create that solution. But what they do is also transfer that into the factory and eventually hand it over into the end customer or into the factory staff. And we do that through these different steps where we have some virtual commissioning that you can do within the tool. It's a sim to real transfer and back. So it's a flip of a switch, literally, on the web browser, whether you're developing in the virtual environment or developing in the physical environment, operating in the physical environment. And it's connected back and forth so that both the simulated environment matches the real and vice versa. So when you're doing debugging or you want to reprogram or change your process, it's very easy to switch back and forth depending on which environment you want to be testing in and exploring in. So this is kind of a static image of what FlowState looks like. I'll just explain a little bit about the tool that we've released. Of course, it's a web-based tool, so you start with a general toolbar, which we're all very familiar with, including the help button, which we need from time to time over on the top right. But the first few boxes or areas of the screen that are most important are where our digital twin is. So this is a scene view, what your work cell is starting to take shape. And also the asset catalog. So assets are the robots, the sensors, the grippers, the models that you load into the environment. We have an asset catalog that's available. You can also import custom assets for your own particular work pieces or models that we don't have yet on the platform. Next up is our process authoring scene. So in this area, you're making your visual workflow. When we think about processes, most of the time we think in terms of some kind of behavior tree model or a sequence of events. In this, you can have parallel processes, you can have loops for failure recovery, for example. Anything you can imagine you want your process to do, you can write that in this visual mode. So talking about the no-code, low-code programming, this is what we're offering here. Behind each one of these boxes, we call this a skill. These are reusable packages, software packages, to build your solution. And many of the skills are very common across all of the automation solutions that we use. And so we provide out of the box many of the basic skills: move robot, activate gripper, maybe capture a scene from the camera, for example. Behind each one of those skills, you can also customize what's happening, or you can create your own skill. And we have easy ways to basically package that up and load it into FlowState as well. So it's a very flexible environment. The next one is our parameter tree. So for each one of the skills, you have certain parameters that you want to change. So for this example, I think it's move robot, and the parameters are what you might find on a traditional teach pendant for a robot. So joint positions or angles or speeds and how you want to control the robot. Those are exposed through a simple graphical interface. Another interface for a camera may have some different things, like you want to see on the screen what the camera is going to see or the simulator in the digital world. So different parameters depending on what the skill is. And you can, instead of using a traditional program language, now you can do a graphical interface to create your software solution. And then, of course, with all good problems that you're working on, there's bound to be errors, and you need to know what's going on. And so we have an output and status bar at the bottom where it'll show you, if things are going great, you get a bunch of green boxes. If you're having some trouble during development, it'll show you, the highlight with debugging status and data information that you can drill down in to help you along as you're developing your solution. So we try to make a very simple and intuitive interface for creating a robotics solution. But to really make it powerful, we need some AI capabilities out of the box. This is the start. There's a long way to go and many more to be added. But with these 4 skills, we feel like you already can do some pretty powerful things in manufacturing. And these AI capabilities are ones that are now proven and working in manufacturing environments, not in our labs. And so we start with perception, giving the robots the ability to see. We can use 2D cameras, we can use 3D cameras with point clouds. It's a very flexible system, kind of goes through the whole architecture of our project. But basically, depending on the conditions and what you're working with, we have different machine learning pipelines that you can use to enable your robots to see. The next one on the list is this grasp planning. So this is a collaboration we're doing with NVIDIA. NVIDIA is building a foundation model for grasp planning, for automatic grasp planning. What that means is you can just take a CAD model, upload that CAD model, and the AI algorithm will tell you where to actually pick up that part. Instead of an engineer trying to figure out what's the best angle, where should I pick up that part, you can use the model to automatically do that. And this means you can be more flexible in your programming environment and change over much faster. Motion planning. So we have a really strong collision-free motion planning algorithm built in as well. This means that with that sight that you have, the vision that you have in your robotics, and what's happening in the work cell, you can automatically change your path if there's new obstacles or changes in the pickup drop-off location, for example. So flexible manufacturing again. And then sensor-guided control or force feedback, depending on who you talk to. This is basically enabling a sense of touch on the robots. It's not the skin environment. These are meant for industrial manufacturing, kind of still in safety controlled zones, but giving the robots a sense of touch. So instead of programming each discrete step, you can use this algorithm to maybe do a connector insertion like we showed before, or a multi-pin assembly process, or you have a stack of parts. Instead of programming each discrete location for a pickup, you can just say, go to this zone until I feel this much feedback and activate the gripper. And so you put all these things together, and what you have is now a much more flexible operation environment where you don't have to program as many steps, and your program, once you're done, can be more flexible to change. So this, kind of high mix, low volume segment that traditionally isn't using a lot of robotics or AI yet because you need to do higher volume to make the payoff worth it. Now with some AI models, we can start to support this other segment of the market as well. So we have a big vision of a platform. We now have a tool called FlowState, but we still have a long way to go to get to that vision. And so what we're doing is we're starting with some practical use cases or industry verticals and partnering with some companies to test out our product, test out our idea, our hypothesis, and get feedback and build and grow and start building more of those templates and those reusable skills that we can provide. And so 2 on the list are kind of metal processing, right? CNC machine tending and sheet metal processing. So in the metal forming, bending, cutting industry, we think this tending application is something where the AI skills that we have available today can provide some real value with the platform. And we're doing that with a couple partners that we've announced publicly. One is Trinity in the US, Martin Systems over in Europe, and Trumpf, who's a big machine builder for metal bending and laser cutting machines. So in each of these cases, we're partnering with them to build a productized solution. What we mean by that is they're building a robotic work cell using Intrinsic's FlowState platform, and they're using that to make a repeatable product that they can sell to do this machine tending process with either their equipment or with their partners' equipment in the cases of Trinity and Martin Systems, for example. We're also doing something similar in the inspection use case. So we announced Newston and Sotec. These are 2 European partners that we just announced at Automatica. They come to us with an AI algorithm for inspection and maybe a camera system or a sensor system, but they don't want to deal with the robotics part. And so we bring in their AI capabilities for the inspection, And we handle kind of the back end of how do you talk to robots and how do you mix and match robots for different customers. This one wants KUKA, this one wants ABB. Okay, don't worry about it. You can just plug and play the solution with different components without having to rewrite the code. We're starting to move into the electronics industry, so very relevant for Taiwan and looking forward to do more there. And we'll be adding use cases and verticals as we grow and go along. So that was, a bit of our journey and where we are today. I'm going to talk a little bit about more that's in our R&D and coming out into production soon. Soon can be this year or a couple years down the road, depending on which one we talk about and how things go. But the first is foundation models for robot perception. So we published a paper at SIGGRAPH Asia last year, our perception team did, which got a lot of attention. They're building a foundation model eventually for the, the ideal zero shot, but right now we're saying one shot foundation model. And we got a chance to test it out a bit at Automatica this year. The idea is we built a model which can deal with very difficult lighting conditions and a diverse set of lighting conditions, difficult parts. We trained the model using all machine, I don't know if I can go back and do it again, I'll try. There you go. We train the model with all different like machine tending parts. Now, we're all amazed with ChatGPT or Gemini or the models that are out there that are doing the LLM integrations. But finding a model that does industrial part perception is not quite as straightforward. You can't find data on the internet for these things. And so we had to build this, and we build it both with physical testing. As you can see, we also did some synthetic data generation as well. And so this is allowing us to now do a one-shot foundation model in a machine tending application, again, where you can just upload the CAD model of the part, and the perception algorithm can understand the part and help you with the locations for pickup, drop-off, and how to manipulate it within your work cell. So this is work in progress, and excited to be releasing it as soon as we can. Another one, which we're doing with a partnership in Trumpf and NVIDIA, is this smart pick-and-place application. So similar, using the perception models, but in this case, we're trying to pick up parts from a stack of, let's say, laser cut machines, or output of a laser cut machine, excuse me, and you want to basically sort them into another bin. This is just an example. You can think of many pick-and-place applications where you might be able to use this. We're using the foundation models and perception that we have, and also some of the motion planning to implement that with less programming at the end of the day. And then switching gears a little bit, we're also building with ROS in mind. I mentioned that at the beginning. ROS, the robot operating system, open source ecosystem, millions of developers, very advanced AI algorithms as well, and as well as simulation models and other tools. We want to be able to make it easier to use ROS tools and for ROS users to use flow state. And so we're working on integrations there. We'll be at ROSCon in Singapore in October, if anybody's going to be coming down for that. I'm based in Singapore, like I said, so very excited about that one. And so we're building with the ROS ecosystem in mind as well. We've done a few demonstrations. We'll have a little bit more this year about how we're making that easier. And this last example is a little bit farther off in our future, but we think it's really exciting and it's really relevant for many assembly applications. So this is a multi-robot motion planning algorithm. What we mean by that is, you saw examples how we're now deploying single robots into factories and using AI skills to manipulate parts dynamically, so not with hard-coded programming. The next challenge is now you have multiple robots in the same space trying to coordinate and avoid each other, and it's a very hard problem. Of course, you've been to factories that are using these solutions already, and they're hard-coded. And it typically takes about a month of a very senior engineer's time to create this type of solution. And you can't change it. And so it's possible, but we want to be more flexible about it. And so our R&D team is very hard at work on this problem. And we've done some demonstrations and examples, but it's not ready for production yet. But we think this is an exciting application that we'll soon be able to build on to add more AI capabilities into our product and our platform. But I also, just to close, also want to emphasize that while we're building some of these tools, we're also looking for partners that are building AI models that they want to incorporate with other robot capabilities. And so we need an extendable, flexible platform that's available for open source, for factories, for research institutions, to combine the best that everybody has to offer and be able to deliver that to the users that need to implement robotics and automation in their factories. And so with that, I will say thank you for the time. I'll look forward to the rest of the speakers and appreciate it.